Okay, advanced chem students, welcome to Monday. I am going to be quarantined the rest of this week. Probably you won't see me till after next weekend. Please know that I'm okay. A little bit of a little bit of that, a little bit of headache, a little bit of fever, but I seem to be pulling through okay. So a few of you have contacted me and told me that you hoped I'd be okay, and I'm fine. Okay. You guys have an exam tomorrow. It will go on as planned. Callan, the substitute, hey, Callan, will be there and administer it for you. No big deal. Today, you guys will take your last little quiz. The grades will show up in Schoology. I'll try to get them transferred over to TAC as quickly as I can, but we'll see how that works out. The practice test that you're supposed to work on in class today after we do that little quiz, I'll post a key for that at the end of the day. So as soon as school's out, I'll post it at like 4 p.m. or whatever, and you can check your answers. The idea is that you would actually take the practice test to find out what it is that you need to review and look over, rather than just look up the answers and just copy. That's not the idea behind the practice test. I have taken, excuse me, the liberty of reorganizing our Schoology page a little bit. We were doing it day by day, and it was like we were all virtual, and we're not. So I have done it in folders instead. So if you open up, say, the homework folder, all of the homeworks that we've done this unit will be there for you to access, and you can see the answers. Same thing with the notes and the labs. If you're looking for notes or labs, you won't have to go find it on a certain day when we did it. Instead, it'll just be in a folder. This is how we organized it before. The school said we couldn't do it that way. We're going to do it that way. But I am going to go over your homework with you. So your the 6 questions from the TEKS, and then I'll give you a little bit of practice. We'll go over the significant figures nonsense that we did last week, so that you kind of have an idea of what's going to happen to you today, but what you're responsible for the test as well. But anyway, okay. So let me see if I can get this, share my screen on my iPad real quick. So I'll go through all these answers with you as quickly as I can, and then we'll do a little bit of practice, and then you guys can take that homework quiz too. So like I said, exam tomorrow. Do your practice exam. That's the best way to study. The things that you miss when you look at the answers, then go back and study those topics. You are always welcome to send me any Schoology messages, and I'll respond accordingly. I'm pretty good about responding. Some of you know this. Okay, so moving on. There were just 6 questions, so this will be pretty quick. Ashley determines density, mass, and volume of a sample of water. And it says, which of these properties should have the same value for both of her measurements? In the repeating, she actually removes part of the sample. So the mass wouldn't be the same if she had less of a sample, and the volume wouldn't be the same if she had less of a sample, but the density would stay the same. Density is an intensive property, so the density is actually, ooh, is it working? There it is. Excuse me, the density would actually remain the same. It wouldn't be all of them. Now, if you measure a cup of water versus a teaspoon of water, it's certainly going to be different, but the density of the water, the boiling point of the water, those things would still stay the same. Number 2, they give you some data. You've got a 2.7 kilogram block of aluminum melted. The resulting liquid is divided equally between 36 square molds. What is the mass in grams of each of the squares that is produced when the liquid solidifies? Okay. So, and it says you have to use correct significant figures. So what we have is we have a 2.70 kilogram block, and it is divided into 36 squares. Now, or 36 blocks, let's say, instead of 36 squares. So let's do 36 blocks. So if I divide those two, let's see, what do we end up getting? We get 0.0750 kilograms for each block. Now, as far as the significant figures are concerned here, 36 blocks you could count. You're counting those 36 blocks. That's an exact number. It's not approximately 36 blocks. It's 36 blocks. So we would look at the 2.70 as our estimation to figure out how many significant figures. And so we need 3. Those 3 would be the 7, the 5, and the 0, because the zeros at the beginning are not significant, but the end they are if yes dot no dot no. This has a dot, so yes, the ones at the end would matter. It does ask for this to be reported in grams. So if I do that, I'm going to use something that we're going to actually, that we're actually going to use in the next unit called dimensional analysis. But if I take my 0.750 kilograms, 1 kilogram is 1,000 grams. So in order to transfer from kilograms to grams, you need to multiply by 1,000. That will give you 75.0 grams for each one of the blocks. That's what it's asking you to solve for, or asking you to get. Couldn't leave it in kilograms. So yeah, there's the same thing. They're just showing you the same thing I did. Much better handwriting though, wouldn't you say? All right. 3 says the density of a 20-gram sample of nickel at 20 degrees C is 8.908. What is the density of a 10-gram sample of nickel at the same temperature? The answer is they would be the same. And the reason they'd be the same is because density is an intensive property. If it's an intensive property, then it doesn't matter how much of it you have, it's going to stay the same. The same thing would have been true of its melting point or boiling point. Those things are intensive to that substance, and so they won't change. Yeah, there you go. There's the prettier version of the same answer. Number 4, student measured boiling points of 3 samples of ethanol. The measured boiling points for the 3 samples are listed below. The actual boiling point is 78.4. So you've got 3 sets of data here, and it wants to know what the reason is for the differences in the student's data. The 78.2 and the 78.5 are pretty accurate. So let's just say that those are okay. The 68.5 is not good. So they're giving some reasons for that down here at the bottom. It says water was used for sample 2 instead of ethanol. Well, water's boiling point's 100 degrees C, so that's a ridiculous answer. The temperature measurement for sample 2 was not accurate. Well, that may be the case. So this could be, if they measured it wrong, sure, they got 68.5. We'll hang on to that answer. The volume of ethanol in sample 2 was much less than the other 2 samples. Again, boiling point's an intensive property, so it wouldn't matter how much of it you had. So the volume's not going to matter. Sample 2 was heated more quickly than the other samples. That won't make a difference either because the boiling point will still stay the same. So it turns out G is actually the reason for the mistake. This person just doesn't know how to use a thermometer. That's sad. Okay. And for 5, a student performs an experiment by dropping an antacid tablet in water. I think we did this. She observes bubbles rising from the tablet. The antacid packaging describes the bubbles as carbon dioxide. So what can the student conclude from these observations? A chemical change released enough energy and caused the water to boil. That's ridiculous. The CO2 is not a product of water boiling. Water boiling is producing water as a gas. That's not true. A is wrong. A chemical change forms a new chemical substance which bubbles out of the water. CO2 is a new chemical substance. This is probably the right answer. I'm going to go ahead and read the other 2, or part of them anyway. They both state that a physical change occurred. No, gas production is a chemical change, so C and D cannot be the right answers. For 6, which of the following would be an indication that a rock sample is a mixture and not a pure substance? This one's kind of strange, but I'll read through the answers. Examining a rock with a hand lens reveals flecks of light color on light color on a dark background. So what you're seeing is 2 different substances there that look different in the light. So that may be evidence of a mixture. G says when strong acid is dropped on the rock, it forms bubbles. That's a chemical reaction. So that wouldn't be an indication that there was a mixture. That's just a chemical reaction that's taking place. An analysis shows the rock contains 3 different elements. Well, fine. There are lots of substances that have 3 elements and are not mixtures. Sugar has a carbon, hydrogen, and oxygen, and it's a compound. It's a substance, so it's not a mixture. So that's not accurate. So these 2 are not right. And then I rather says the rock consists of crystals, but they vary greatly in size. You don't know that. You're just looking at it. So I really think the best answer is F. This one's kind of a dumb question, but you can kind of see that they're different. Having crystals vary in size. If you had salt, you could have salt crystals that are bigger and smaller, but it's still salt. It's just a silly question. The answer is F. And so then let's just do a little bit of sig fig practice for you before you take your quiz. It's just nice of me. So it says how many sig figs? So what I'm going to do is tell Callan to just pause this and give you guys a minute or so to kind of go through there and do these, and then I'll write them up there real quickly. Okay, so pause. Okay, so I'm assuming you paused, or you just waited for me to give you the answers. We'll see. Okay, so the first one would have 2. Yep, because there's no decimal. We could change that by adding a decimal there. That would give me 3, because if there was a dot, the ones at the end would count, but there's not, so it's 2. 3010 was 3. 3.100, yes, dot, so this is 4 total. This one, the beginning is never, so this is 2. This one would be 4. This one would be 5. Holy cow. This one would be 4. And the last one would only be 2, because there is no decimal there. Even though it's 510, the beginning zeros are not significant, and the last one's not, because there's no dot. As far as addition and subtraction on these, I've got 25 plus 3 plus 1.02. Oh, I'm doing this in my head. That's bad. So that's 28, 29.02, 29.02. However, this has none to the right, this has none to the right, and this has 2 to the right. We called them digits after the decimal. So the dads, 25 has no dads, 3 has no dads, but 1.02 has 2 dads. The one that has the fewest dads is the one with no dads. So what we do is we lose this, and it ends up just being 29. So 29 would have no dads. That's just for addition and subtraction. For multiplication and division, you will multiply. Now we're assuming these are both measured values. You have 25 times 3, which is actually 70, which is actually 75. You could go so far as to say it's 75.0. However, this is only one sig fig. And if this is, we're assuming this is a measured value, then this would actually be rounded to 80 with no decimal. So kind of odd, very strange there, but if that were the case, the answer would actually be 80. So that's it. Test tomorrow, do your practice test. If you guys have questions, message me. Feel free to ask Helen anything you want. She's bright, she knows what she's doing, and we're glad she's here. Okay, I'll see you guys soon.